Let me talk about domains and magnetism here. Um, I'm talking about like permanent magnets, right? Concept zero is that ferromagnetic materials, like let's just talk about iron, right? Um, actually have these little domains or small bits or millimeter, submillimeter size that tend to align. They tend to vote together. Um, so like this might be a domain, and its north might be there, and its south is there, and this is north that way, south that way, right? And so that's concept zero. And concept one is that if you have a permanent magnet, what's happened is that more of the domains, like this one, this one, this one, this one, right, are pointed this way. The North Pole is on this end, and the South Pole's there, right? And the more magnetized we make it, the more we flip around these domains, right? Where if we had something like this, it would be very, very highly magnetized, right? Okay. Um, so the extent that we can get these little tiny domains or collections of atoms, right, to vote in the same direction, then we actually magnetize it. It becomes a permanent magnet, right? So the first demo I do is I take a metal rod. I wish I could show you this. I'll see if I can find a video of it. And I basically just hit this end with a hammer. Right, I hit this end with a hammer, and I hold it in Earth's magnetic field. And let's say I may point this side toward north and this side toward south. If I just beat on it, the domains in this will flip around until this magnet becomes a north pole that way, south pole that way, right? And then I can flip it around. I can take that thing that I've magnetized, flip it around the other way, beat on it, and it'll go back to. I can make it. I can change it from north to south and south to north, right? So that's something. So one way to do it is to physically strike the magnet. Now, with that in mind, if you have permanent magnets, don't bang, don't jar permanent magnets. Permanent. Don't jar them, because that will actually cause the domains to randomize, right? So that's one way to demagnetize something, is to just hit it without a magnetic field around it. Another way to do it is to heat it up really hot and then cool it down. So you heat it up inside, say they get a magnet like this, make a giant electromagnet, and then stick this thing in here, heat it up with that external magnetic field applied to it. This is supposed to be a coil, okay? And that just doing that way, and then when you cool it down, this thing will have it'll remember that. You have to heat it up pretty hot though. I think it's like white hot. Another way to do this is to use electromagnets, and this is the second demonstration I do. Okay, because I use something called hysteresis. So this is let's say that this is the induced magnetism, and then this is the external magnetism. And what I'm talking about here is that we have a coil like this. Let's see if I can draw a better coil, right? And we've got an piece of iron in the coil, okay? As I put current through this external coil, that if we look at the domains in that center one, they start to respond slowly, then they start to respond faster and faster, right? Then they respond at some maximum rate, and then they, as we apply that external field, they, diminishing returns, right? Okay, this is what's going on right now. If I bring it back down, if I drop that back down, there will be some residual magnetism, right? Okay, and so what I'm going to do, or what I do with this, is I get a coil, and I've got a big old coil like this, right? And I literally plug this into 110 volts, right? Except to complete the circuit, I've got a little piece of aluminum foil like this. And I plug this into a plug, literally. It's one of the most dangerous demonstrations I do. So literally a plug into 110 or 120 volts, right? I plug it in, and what's going to happen is it's either going to go south or it's going to go north. It's going to break, though. It's one of these peaks, right? Okay, like that. It'll break here or it'll break there, right? Okay, and then what happens is it snaps from here to this axis, and we have a strong residual magnetism on it. Anyway, that's another way to magnetize magnets. I'll see if I can find a video and post that as well. But anyway, that's that.